Last week, we have started to talk about characteristics of the method validation. So first of all, could you remember what items that we have to be included in the method validation? So first one is the selectivity. So last week, I have talked about the selectivity or so-called specificity. In the method validation, if we have to carry out this selectivity, why we have to carry out? Because we have a lot of other impurities in our sample matrix. So in order not to be interfered by our other impurities, so we have to have a very specific and very selective. The selective is to target our analytes that you have to be detected in your method, no matter you use instrument or not, okay? So last time we have talked about, because we have a sample here, so this is our target, but we have a lot of other impurities in our sample as well. So let's, if we used HPLC as our instrumentation detector method, normally it will have it will give better separations if your method is well developed. So in your chromatogram, you have a lot of peaks, okay? So last time we have talked about, you have to develop a method that is selectively detect your target analytes, okay, which will not be interfered. So if you learned the HPLC before, if the peaks is co-elute with other impurities, that means this method is not selective, okay? So you better have to fine-tune your method before you carry out your full set of method validation, okay? So you have to be have a method that is specific and very selective. So if you have two target analytes, obviously you will have two separate target 1, 2, etc. Okay, so more target analytes in your solutions that you have to be detected. You need a more well separated method to be developed. Okay, so this is the one of the characteristics that we have to be done or to be considered when you perform the method validation. Okay, so the first one is selectivity. So last week we also talked about another characteristics. Do you remember what I have been covered? So this the other one is the limit of detection, okay, and also limit of quantitation. So usually these two items will be done together in the method validation if you have been selected to be one to be your parameters that you need to study. Okay, so LOD is the limit of detection, where the LOQ is limit of quantitation. Okay, so you have to, depending on which international guidelines that you follow. Last week we taught on EuroChem. Okay, so normally they will choose the signal to noise ratio greater than 3, whereas the signal to noise ratio for the LOQ will be around signal to noise ratio greater than 10. Okay, so for the LOD, in some of the testing lab, if you have some experience of sending some samples to the testing lab, Some of the testing lab, let's say if you would like to test, okay, in my choice, whether the phthalates content is meets the some of the European guidelines or European standard. Okay, so hopefully your choice, hopefully you don't want any phthalates being in your choice, okay? Otherwise, because maybe some of them are the banned materials that it won't allow to be included in the choice because it may be harmful to the kids, okay? So in the testing lab report, some of them, the LOD, maybe I can say in this way. In the report, some, let's say the amount of phthalates, okay, some of the report will say ND, that is not detected. So what does this mean is because they have done their method validations with the limit of detection. So any level that is lower than the limit of detection, they will report it as ND, okay? For the LOQ, they have done some of the studies, and they will confidently detect at a certain level. So some of the reports, if your samples have contained some of the phthalates, which is in between the level of LOD and LOQ, let's say the LOQ of that laboratory of that particular method is, let's say, just an example, 5 milligram per gram, okay? Maybe this is their LOQ, okay? And the LOD is 2 milligram per gram, okay? So ND here is, that is anything that is lower than 2 mg, they will report it as ND. So if your samples is in between 2 to 3, then they will report it as smaller than 5 mg per gram in the report, okay? They won't give you an exact value of 3.5, 4.38, something like that. They won't, okay? For anything that is the your sample higher than 5 milligram per gram, then they will report as a particular specific concrete value for you. Let's say, depending on how many significant figures that they are comfortably reported, they may say, oh, your samples will contain 6.5 2 milligram per gram in your samples. Okay, then this is the exact values. They will report it in the test report. Okay, so it gives you some ideas why they have this kind of reporting styles and giving values for you in the report, and why we have to include LOD and LOQ in our method validation. Okay, so these two values we have been talked about last week as well. And what else? What else did we talk about last week? We have started to talk about a little bit on, do you remember what I have been ended last week? It's about calibration. Okay, so last week we have talked some about calibration, but we haven't finished it completely. So tonight we will continue from the calibration to talk about it, and then continue with the remaining method characteristics items that we have to be considered in the method validations later on. Okay, so calibration curve, we talk about why we have to build up the calibration for determine the correlations between the concentration and our signals. Okay, and we have talked about, do you remember how many what's the number that I would like to suggest you to prepare in performing the calibration? Can anyone text in the text box for me? Yeah, last week for the calibration, the number of the standard that I would like to suggest you to prepare is 7. And is there any specific requirements in preparing these 7 standards? We have suggested you in preparing this 7th calibration standard. Yes, we have to have a evenly distributed concentration. So suggested 7 standard to be prepared in the calibration curve, and ideally is evenly distributed. Okay, so if it is okay, we would like you to prepare these 7 standard solutions one by one without any further dilutions that I have been talked about, because any errors that you prepare in the stock will propagate to the next one. Okay, so we would like to have a well-trained chemist or analyst that can be able to have the good weighing techniques, okay, and also the dilution, not the dilution, is if you prepare the standard in the volumetric fast, you should have all the techniques that have been well trained, okay. But if your balance cannot support that small amount, because when you prepare those 7 standards, because some concentration may be very, very low, in which may not be able to weight it in the balance. Okay, so in that case, then you have no choice. You have to prepare a certain higher concentration level as a stock to dilute it. Okay, try to design your calibration as to minimize the use of the further dilution. Okay, to minimize these kinds of errors. Okay, so this is the calibration points that I have been talked about last week. Okay, so let me move to the certain page in the PowerPoint first. Okay, so here we also can refer to some of the different guidelines. Okay, so some of them even maybe suggest you to up to 10. Okay, but I think 7 will be sufficient in some cases. So please check your standard carefully, what's their minimum or suggested requirements if your method validations, or if your method is going to be used according to that guidelines. Okay, so and also for the calibration, you need to, let's say if you use HPLC, you need to inject your samples, some of them is duplicate or preferably triplicate in NATA, okay? So for, let's say, UV, you also need to measure your absorbance for that particular same solutions twice or in 3 times, okay? So please check carefully what's the standard that you have to be followed, okay? So in this figure, it's to illustrate in the graph with the at what particular point is referring to the linear range or the calibration curve. Okay, so maybe in here, we start to prepare the standard from 0, okay, let me up to the last point, 1.2, okay. So across this concentration, you will prepare, let's say 7 concentration across the 0 to 1.2, okay. So this is the calibration standard that you have to be prepared, okay. So and maybe in a certain range, it gives you a linear range, okay. So for the working range, starting from the point of the LOQ, okay. So just now I have also mentioned the LOQ is at a certain level that you will comfortably to report the amount that you have detected. So in that case, this working range here, okay, this working range here is the range that the analytical procedure is started from the upper and the lower range, okay. So in this level, it has already demonstrated with a suitable level of the precision, accuracy, and also working range, okay. So in the calibration curve, you will have some linear and some take of the atoms. First of all, understand the theory behind and do according within the BS law, because in BS if there is any concentration if you linear measurements, it's not the nonlinear properties of your analyte, but is originally from the BS law, okay. So make sure you prepare the concentrations in your calibration curve if you measure with the UV, okay. Even though I say, oh, prepare the 7 concentration, make sure that those 7 concentrations is within the BS law govern, okay. So sometimes you will have the linear and sometimes you will have the nonlinear curve that you will be obtained, okay. And ideally and normally we will have this kind of the curve that can be obtained after having the measurements with those 7 standards with the signals that you obtained, okay. So if it appears to be have the linear relation, these test results will have these appropriate statistical methods, okay. So you will have the R square and also the y-intercept slope, okay, and to give you some of the information for you to calculate your samples concentration, according to the established calibration curve by your 7 standards, okay? So in here, you will have 2 curves. One, which is have the left one, A, has a higher amount of the correlations because you can see it much fall into a straight line, whereas the B one will have the lower, okay, even though they will have the same equations, but from the points that it's shown, the B one is not fall into the line, okay? So of course the A will be better, okay, to claim as a linear one. So normally you will have to use some of the equations to calculate, okay? And here sometimes you will have some points that is outlier, okay, which is not fall on the curve, okay? So maybe you have to remove those in some cases. And here you can see some of the points is a bit deviate, okay? So we call it leverage, okay? And we have to do some leverage, and because of those outlier, okay? So in these plots, you have to some outlier is a result which will be different from the rest of the test data here, okay? This the red point, okay? So in the case of the calibration, the outlier will need to be removed in some cases, okay? So we won't to be affected, okay? So this will have the leverage on that, okay? So maybe we have to remove it. And you can see a red point, that is some of the inference bias that may be observed here, okay? So we also need to be remove it because it will shift the entire line upwards if we include this red point, okay? So you have to interpret your or analyze your curve once your data is obtained. So in here, the red point is the observed, that is the experimental one, experimental data that you have, okay? So and the blue line is the is by using the Excel, you will plot the curve, okay? So in here, we are aiming to have linear regressions, okay, with the given intercept and slope, okay, but we have to consider the residue, okay. The residue is the point from the observed and the estimated one, okay. So you will have the y-intercept and the slope, okay. So you can plot, you can insert your concentration in the equation, then you will get the estimated response that you have, okay. So the difference here is the residual, okay. So you have to note this value, okay, when you calculate your calibration curve, okay. So the sum of the square residuals for the poor dash line, okay, will be much larger than that for the solid best fit line. So the blue one is the best fit line, and the dotted line is the sum of the square residuals, okay? So here is the, once you get the difference here, then you can plot the residuals with your concentrations, okay? So actually it's the difference between the estimated and here, the estimated one and the observed one, okay? So this is, after you plot the residual plots, then you will have some cases you will have the figure 8, sometimes we'll have figure B and C. So this is some of the characteristics with the different outcomes, okay? So the first one will show the correct approach that you have chosen. The residuals should be very at random, okay? Whereas the others two are not, okay? So normally in some of your experiments, you need standard addition, okay? So when you need standard addition, because maybe your sample matrix is a little bit complex, okay? So you need to consider the matrix effects, okay? So then you need to consider to establish the standard addition when you performing the calibration curve. So when you perform the studies of your analytes, you will know more about it, okay? And then you choose the appropriate one when you establish the calibration curve. So once you know how to prepare it, then you perform your method validation, and in your routine analysis, you have to follow what you have been used in the method validation. Okay, so this is very important. Okay, so in the method validation, you need to study it thoroughly. Okay, so because once you know the properties and all the levels, let's say LOD or LQ, etc., then it will be used in your routine analysis. So these are the points that to be considered in the calibration items in the method validation. Then we will move on to talk about the next one is about trueness, that is the accuracy. And the next one will be the precision. So in here, you can see 4 figures, okay? So ideally, we will like to have the accurate and precise data or the result in our method validation as well as in the routine test, okay? So all of the points will be hit on the center, okay? This is the ideal one, though. And for some cases, they are accurate. That means they are close to our target. The target is at the center, okay? But they are not precise. Precise, that means all these data, the data point will be fall closely, okay? So the bottom left hand side will be so-called accurate, but not precise, because you can see all those 4 points close to the center, but these 4 points are not nearly stick together, okay? And the right-hand side, the upper one, is they are far away from our target, far away from the center point, but these 4 results are very close together. That means with the similar result, okay? Whereas the poorest one is the right-hand bottom one, which is scattered all around, which is far away from the target, okay? The target in here, let's say, is our reference value, okay? Let's say it's 100, maybe 100 ppm, okay? So if all the points are for about 99.9, these 4 points, then we can conclude that we have an accurate and precise data, okay? So this is the idea of the truthfulness and the precision, okay? So in the truthfulness is the measure of the accuracy, which is the closeness of the agreement between a test result with the accepted reference value, okay? So, and how to address, some of them will have some method bias, okay? So, so how to address the method bias? You can use some CRM, that is certified reference material, to compare the true or the accepted true values, okay, by use of these reference materials. And it will give you the measure of the method bias, okay? So, and maybe you can compare the method with another method, okay? And sometimes you can also use the gravimetrically spiked samples with the blank samples in performing in finding the method bias, okay? Okay, and in the bias, that is, let's say, this is the bias. So the bias is the mean value of the spiked samples minus the reference value. This is so this is the x is the mean value of the spike sample, okay? So the x ref is the reference value, okay? So sometimes you will calculate it in the relative percentage, okay? Maybe in here, maybe you will to calculate from the okay. Maybe you will correspond with reference to the reference values, okay? So you have to calculate on your own by using some of the mathematical equations, okay? So, and when you performing the truthfulness, then you can consider some of the bias as well, okay? So the reference value will, when you use the CRM, then you will note the reference value, or because you will prepare your target samples, because when you weight it, then you will note how much you weight, okay? But when you then you will note the reference value, or if you are not using the CRM, sometimes you will use your spiked samples. When you weight it, you will know what's the amount that you have weighed, okay? Then you will have the amount, okay? This is your finded values, okay? This is your weighted values, okay? Then you will know it. So for the bias, you will have method bias and the lab bias, okay? So when you consider the bias, you can also look into some of the bias is contributed from the method, and some may be due to the laboratory preparations, the work, okay? So it may be contributed from these two these two items. Okay, so you have to note it when you consider the bias in your method. Okay. So about the accuracy in the pharmaceutical industry, they will also prepare. So how they perform the accuracy in the validation, they will sometimes use the standard addition techniques if they think it is appropriate, or sometimes they will use the spike. Okay, so but in the preparations, let's say if the target, let's say if my paracetamol, if our paracetamol tablets, let's say if 100 milligram, okay, let's say my target is 100 milligram, okay, so when I perform the accuracy in the method validation in the pharmaceutical industry, they will, in here, they will prepare 3 concentrations covering with the 3 replicates for each these 3 concentrations. So the target of 100 milligram, we will target on. So sometimes we will take about 80% of the target as the lower concentration in our accuracy prepared samples in the method validation. And for the higher one will be 120 milligram. Okay, so suppose this is the 3 concentration, 1, 2, 3 concentrations that we have to be prepared in the accuracy method validations, and each of these 3 concentrations we have to do 3 times. Okay. So altogether, you will have 9 determinations. Okay. By using this 9 determination, you will calculate the accuracy. Okay, the recovery. Okay, then because you will weight the because you spiked it, because you weight your target. Okay, so you note your target values, and then you have your experimental values. Then you can calculate the recovery, which is shown in the next slide. Okay, in this table, it's just some ideas of how you have these 9 determination with 3 concentration. Okay, in here the target is 100, and it use 50 and 150 as the lowest and the highest concentration to be included in the accuracy. Okay, so the pharmaceutical industry also has the requirements. So you have to check depending on what's your purpose. Okay, even you performing the accuracy in the method validation, depending on you are targeting on detecting the active ingredients or impurities, or some of them is to detect the active in the dissolution method. So depending on the purpose, the accuracy setting of those 3 concentrations may be different. Okay, but this is some of the ideas for you to have a look on. If it will suggest you to prepare 3 different concentrations with 3 triplicates for your accuracy experiment in the method validation. And they also have their requirements. Okay, let's say in this we have a good recovery with 100, about, okay, with about 100%. Okay, but in some of the analytes, because it may be hard to be recovered. Okay, so in some, let's say in food matrix or in some others, so check according to what you are going to be tested. Okay, you study about your industry or your international guidelines. Okay, so they will have some guidelines for you. What's the acceptance criteria when you're performing the accuracy in the method validation? Are we have to follow all 100, or actually maybe some analytes we can accept maybe, let's say 80% recovery will be fine. Okay, so it depends, but please check according to your guidelines first. And this is some of the suggested acceptance criteria in quantitations of the impurities and the assays in the drugs. Okay, this is just some of the ideas. So you have to fall into what's the guidelines suggested. And this is some to remind you to consider the bias, okay, when you perform the validation, okay. So the next one will be the precision, okay. So also back to the target points that we have talked about. Okay, so precision is those data, those points that you detected closely together. Maybe it is not hit on the target, but it's close together. Okay. So the closeness of agreement between the indications or the measured quantity values obtained by, also you need to have the replicates measurements, okay? Just like the accuracy in the design of your precision method validation, you also need to have replicates, okay? So if you remember, last week when I introduced the characteristics of the precision, there are two items to be included in the precision. One is the repeatability, okay, and the other one is the reproducibility, okay. So the first one is the repeatability. So will be performed in the same laboratory in a very short period of time with the same analyst, okay. And to study any random, any errors that obtained by a particular persons within a short period of time, okay. So ideally, if the analyst A is being well trained and with good techniques, and suppose they will perform he or she will perform the same results, will give the same results, okay. So with the closeness with repeatability, okay. For the reproducibility, okay, so maybe you will ask another analyst in your laboratory to perform. If you have two pieces of HPLC, maybe you try to ask him or her to use another piece of instrument, okay. I'm not saying that to use UV instead, no. If you use HPLC as the instrument detector, then you try to use the same not the same piece, but you also need to use HPLC as the instrumentations method in the method validations in this precision study as well, okay. You may not necessary to ask the analyst B to perform on the same day as the A. Maybe you ask him or her to do this maybe next day, or sometimes maybe next week, okay. A little bit longer time, okay, to study, because in the routine, you won't rely on a particular analyst in your laboratory, and maybe that's not the good case as well, okay. So you hope that the result or the performance of your method will not be depending on the person, okay. So we will have this kind of study precision in our method validations to know is there any variations between analysts, okay. And similar case, if you have different pieces of HPLC, then hopefully we won't want to have different performance among different HPLC, okay? And if it is okay, or you can find another laboratory to support, then it will be better to have the inter-laboratory reproducibility, okay? And if not, then you have to skip it, okay? But because I know some of the lab may not be supported this inter-laboratory reproducibility, but at least you have to do the reproducibility of the intra-laboratory as well as the repeatability within your laboratory, okay? Because sometimes if some of the testing lab have maybe globally, okay, so if they have the let's say the member in Singapore or maybe in mainland China, they can ask them to perform it, okay? In my first lesson, I have bring out, you have to be aware of the different countries will have different temperature and humidity, right? If your test method or if your analyte, it's very sensitive to the temperature or humidity. So in the inter-laboratory studies, make sure that you have highlight what's the conditions or the humidity, temperature, etc., that you required to perform to let your the global laboratories partners to note that, okay? Because you know some of the Asian countries is very hot and humid, or which may not be the same conditions as in Hong Kong, okay? So in here, it's just a summary for you to note that the repeatability for the operator instrument and the calibration and the laboratory will be the same and within the short period of time, okay? Whereas in the intra-laboratory, use different operator. Sometimes if no other piece of the HPLC, let's say, okay, maybe sometimes even maybe not have two pieces of mass spec, okay, then you have no choice. Then you ask another analyst to perform it with the same, let's say, mass spec, okay. But with different calibration and stay maybe next have a longer period, okay. Where the reproducibility in the inter-laboratory, then you will have this operator instrument lab will be different, okay? But you provide your samples for them, okay? So we hope that the variety will be very small in performing the repeatability, whereas we accept a certain variations when we perform the inter-laboratory reproducibility studies, okay? So in the precision, we will also like to, so I have mentioned for the accuracy, you will have 9 determinations according to across 3 concentrations, 3 replicates, okay? So I take an example in the pharmaceutical industry, okay? So we will, in the precision studies, it will also accept 3 concentrations with 3 concentrations with 3 replicates. So that means altogether is 9 determination as we do in the accuracy, okay. If not, maybe this is one of the option in the pharmaceutical industry. If not, then you can have minimum of 6 determination. Okay, so this 6 determination, okay, can use at your 100% concentrations. Okay, that means as what use the example as the precision. Let's say 100 is the target one. Okay, then you perform the 6 determinations at the 100. Okay, for the A, if you have the ability, then I will go for A. Okay, so you can also choose 3 different concentrations across, and also you have to bracket with your target. So let's say, oh, maybe, okay, 50, 100, and 150. Okay, so you decide when you perform your validation. Okay, so before we move on to the next items, maybe we take the break here first, and then we come back at 8 o'clock. Okay, we come back at 8 o'clock. Okay. Testing. Okay, so let's continue with our remaining parts. Okay, so I usually suggested you to follow some of the guidelines. Okay, so some of you may interested. So can I referring to one of the international guidelines? Let's say I use the NATA or the EuroChem requirements in the, let's say, selectivity, whereas in the precision I use another. If you do not have a specific requirements to follow a particular international guidelines, I can't say you cannot. But if you do not have a specific guidelines to follow, let's say I don't need to follow because of my method, I don't need to follow exactly EuroChem. But I would suggest you to find one of the most suitable guidelines that you can, international guidelines that you can follow, and don't just cut one from here and obtain the others from there. Okay, but in some cases you have no choice, then you can have some justifications or you make some risk assessment on your own choice. Okay, so I would suggest you if you do not have a, so first of all, if you have a specific requirements, let's say if you have to follow your countries have to follow, let's say EuroChem, then you have to follow. Okay, you have no choice. But if you have no restriction on any specific international guidelines, then you can find one for your laboratory, okay, or maybe for that particular method validation purpose, and then you can choose anyone. Okay, but when you obtain the specifications or the requirements, try to obtain the full set from a particular international guidelines if you can follow. Okay, you need to make some justifications if you just take those less stringent one. Okay, because usually why you use the other not to follow exactly the same, because maybe the others is less stringent and you can meet the less stringent one. Then this is the reason why you choose different guidelines in your method validation. Okay, so after we talk about the precision, then let's move on to the next one is the rootedness, or we call it robustness. Okay, in these studies, test in the method validation is to study the ability of the analytical method that will be remained unaffected by some small changes in your experimental setting. Okay, so those settings can be maybe is your sample preparations. Okay, to study whether there are some inference from these method parameters. Okay, so maybe in some cases you can change, let's say the column temperature, maybe one of the items that you can consider in the robustness studies. Okay, and maybe different batches of the reagent. Okay, and sometimes maybe a small change in the maybe the mobile phase composition. Okay, in some of the study, people may use this small variations changes to study is your method being affected by this small variation. Okay, so you can design in your experimental. So with the same preparation as the normal, but with some changes, let's say but you don't change all these different items at the same time. Okay, so let's say if I normally use, let's say 25 degree in the column temperature, maybe now I will increase a little bit, let's say 27 or 30. Okay, then to see if there is any changes or any influence. Okay, and sometimes maybe you change your different batches of your reagents. Okay, then when you change different batches of your reagent, you remain the 25 degrees in your column temperature. Okay, so you don't change both of them simultaneously. Okay, so so actually these two terms are very similar. Okay, and some we won't treat it as a different one. Okay, so as the whole studies, you can include it no matter ruggedness or robustness. Okay, you also can consider some of the external factors and in reagents that I have been suggested, and some maybe the internal the setting of your instruments. Okay, so you can have a slight variations in these studies. Okay. So this is the suggestion. Okay, you can also consider the extraction time in your studies as well if your method include some of the digestion or extraction. Okay, and you can also consider the use of different lots of column as well. Okay, not only to study the different reagent batches, you can also study the columns, different lots. Okay, maybe from different suppliers. Okay, and maybe you have some changes in your buffer solutions, or maybe in sometimes maybe in UV you can have any small changes in the wavelength. Will it be there any influence on your method performance? Okay, so in the ruggedness and the robustness test, you can consider. Okay, this is also some suggested items that you can consider. Okay, so the next part will be to be included in the method validation is the system suitability. So in the chromatographic method, normally you have to consider the system suitability as well. If you can remember, suppose all of you have learned HPLC or GC, right? So you will note that there are some requirements on the resolution. Okay, the resolution is how well that the different peaks being separated. Okay, and the telling factor. The telling factor. Okay, whether the peak is having some telling on that. Okay, so there are some requirements, and especially in some of the pharmaceutical pharmacopoeia in USP, let's say, they will list out some of their requirements for their monograph. Okay, so if you have to follow or if you have to use their method exactly the same, then you have to check whether your system suitability has met their requirements. Even you are not following the USP method, but if your method is using is chromatographic, then you also need to collect some of the data about the system suitability in these terms, in this theoretical plate count, telling factor, resolutions, and the RSD of your retention time as well. Okay, so you have to set the criteria or yourself, or you can with reference to the USP. They will normally let's say the retention time, the RSD retention time normally is less than 1%, sometimes maybe 2%, okay, depends, okay. And the resolutions maybe 1.5, okay. So you can check accordingly, okay, to set in your specification, okay. And for the method validation, one of the method characteristics I would also like you to include is the solution stability, which I have mentioned in the first line in this method validation notes. The solution stability, okay. In some of the practice, then they would like to include the solution stability. So what's this include? What kind of studies that we have to be taken in the solution stability? Because normally, let's say HPLC, okay. So you prepare your standard. Okay, and your sample. Okay, so because you don't know how stable of these solutions that being prepared, let's say today I prepared in the solution, some of the analytes may be not stable in solutions, okay? And because maybe as what we have in the, let's say in the calibration, right? You remember I suggest you to have 7 calibration concentration with duplicates or duplicate injections or sometimes triplicate injections, okay? And depending on your runtime in your HPLC, if you use UHPLC, then the runtime will be shorter, okay? In normal cases, okay? It depends on the properties of your analytes and how complicated of your chromatogram, okay? But in some of them, some of the method, maybe the runtime of a particular run will be very long. I just have a little bit exaggerated, maybe a certain one injection, maybe it takes 60 minutes, okay, an hour, okay. Can you imagine you have 7 concentration with 2, just an example, maybe duplicates, okay, but you will have 60 minutes, okay, so 1 hour. So that means you have to use 14 hours to build up your calibration, okay. But although it is automatically injected in the system, once you put into the sample tray, then it will inject it automatically and then you can go away, okay. But you have to know the properties of your standard and your sample, because maybe after 14 hours, then you will inject your samples, okay. So how stable of these solutions, you don't know, okay. So in the solution stability, you try to design an experiment that to study how stable of your standard and the samples can be kept, okay. And this is also being good for you because you know better how stable of the standard and the sample, then you can prepare in advance. If your samples and the sample is very stable, then you can prepare in advance all your samples and you just let the sample to be cured and to queue up the line and then being injected by the machines automatically. If not, then if the sample solutions and the standard is are not very stable, then you should be prepared freshly. Okay, so this gives you an idea. And also in the routine analysis, maybe you noted that if it is stable, I just need to prepare the standard. Maybe we can keep for a week. Okay, maybe when you study the solution stability, maybe you can also try to note how long can you keep the standard. Okay, so if the standard is very stable, then you can keep it for a week. Okay, then you don't need your analyst to prepare it every day if it is very stable. Okay, so try to have some studies, then for more better understanding of your standard, then you can have less work in your routine. Okay, this is one of the purpose of doing the solution stability. Okay, and also you know if the sample solution is not very stable, then you have to prepare your samples very close to your after you inject your standard. Okay, suppose your runtime is very long. Okay, this is just an example. Okay. And in the pharmaceutical industry, it will also include a stability indicating assay in the method validation to study any impurities or any degradants being found after a certain period of time. Okay, so because for the drugs, for the drug substance, it may be degraded. Okay, at the very beginning, you note the target. Let's say if in a QC laboratory, and then you noted that let's say I also use the paracetamol as an example. So this is the drugs, the active ingredients. Okay, the active ingredients. Okay, your assay method will be just target on the paracetamol, but when the paracetamol is being put along the shelf life, maybe 3 years. Okay, there maybe have some impurities. Okay, so-called, let's say, impurities A, impurities B, and sometimes maybe degradant. Degradant is being degraded according to the time. Okay, maybe it's not originally found at the time point 0. It may be found at, let's say, after a year or after 6 months or else. But at the very beginning, when you prepare the method, you will prepare the method at time 0, right? You don't know what will happen in the drugs. Okay, so we will try to, at the very beginning, at time 0, we will try to stress our samples. Okay, so in this stability indicating studies, we will try to put our samples in some hash conditions. Okay, in order to have some ideas on what kind of impurities or degradants will be found. Okay, so the first one maybe heat or humidity. So maybe we put the drugs in an oven, let's say in 100 degrees or 70 degrees, and then put for some times, and then to test the sample. Okay, so we try to be ready. Our method can detect it these samples, after being put under heat for several times, maybe there will have some other impurities apart from the times 0 paracetamol products. Okay. Another options, maybe we would like to put some acid, okay, to hydrolyze the samples. Okay, they may, some of the ingredient may be hydrolyzed, so we have some prediction on what kind of degradants on that. And maybe we use, let's say, depending on what kind of concentration, maybe you can use HCl, okay, to perform the hydrolysis. And then maybe, okay, you can also use base, let's say sodium hydroxide, just as an example. Okay, so depending on your sample properties, then you can use certain acid or base for your sample design. Okay, the peroxide, that is the oxidation. Okay, and you can use the peroxide, hydrogen peroxide, to be put into your samples, okay, for a certain time, and then you perform as what your originally designed procedures, and then inject into the HPLC. Then you can have the chromatogram, and maybe light. Okay, so maybe you can use UV light, okay, to put into the box, your samples to be put into the UV box, okay, to photolyze your samples. Okay, this is some of the suggested method when you design your the stress studies for your samples. So maybe in the food validations, you also have your some of the requirements. Okay, so this is just some examples. If you have, depending on what kind of food, okay, maybe you have to design your validation according to the matrix. Okay, so the next slide will show it according to the Hochul's requirement. Okay, you have to select 5 different common food matrix, and also from the 3 food types of the representative for each food matrix. Okay, so the food industry has their own requirements according to Hochul's. Okay, so you check and you follow what you need. Okay, in here you can see that altogether you have 15 food matrices in the validation studies for the food analysis. So the items, the method characteristics, method validation characteristics items have been gone through. Okay, so here we'll list out some the deficiencies of the in the method validation, and you have to be noted on that. Okay, this is just some of the examples, and to let you know it. Okay, in the food, maybe you don't follow what exactly the number of the food matrix and the food types, as I have just mentioned. Okay, so, and maybe you forgot to have enough concentrations in the working range, and forgot to have the reporting limit to be verified. Okay, and some of them maybe the validations data may not be done accurately. Okay, so in the method validation, you have to be aware of what elements that you have to be include. Okay, don't skip or don't miss anything. So about the strategy. Okay, first of all, you have to plan it. You have to think what you want to do it, okay, you have to develop your whole project plan, okay, and you have to have some research on your analyze target, and also what kind of the equipment that you have to be selected, which fit to analyze your target, okay, and in the plant, you have to set some of your specification as well, okay, and any requirements, any adjustment on your parameters, okay, and what kind of the method characteristics that you have to be include, etc. Okay, so you have to discuss it and you have to evaluate it. So in the reports, so that means you have to report what you have found, okay, and do you meet your client requirements? So you have to draw some conclusion as well, and then you have to in the report you have to list out all your used chemicals, reagents with their certain batches, suppliers, etc. It's very detailed, okay, because anything you happened in the routine, you have to check back to your method validation reports, because your routine method, why you can use, because you have already validated your method. Anything you have being used in your routine is extracted from your method validation, okay? So your reports should be listed detailedly, okay? So the step, calculation, etc., or any precautions, you have to list it out very in a detailed way, okay? Because the method validation may be done by you, okay? You remember in your mind, but you may not be stay in that lab for a long time, okay? Maybe the method will be transferred or maybe used by another analyst, okay? So in the routine use, if there is any issues or other things, they will check back the validation report, okay? So try to list out all the details things in the report. So in here, as I have suggested, all the calculations, what kind of plots or what kind of the mathematics, statistical use, calculation, etc., you have to be listed in the report, okay? And if you have some reference guidelines that have been followed when you perform this method validation, you also need to be listed out, okay? Because the people can also refer it, okay? If they have any questions about that, they can check back to that particular reference guidelines, okay, to have some more ideas, okay? They can study it on their own, okay? If they perform the validation again, they can also refer to the reference again to study it detailedly, okay? Maybe there are some update in the literature, maybe you refer to the 5 years ago's versions. Okay, so nowadays maybe there are some changes in the latest one. So they will know which particular versions that you referring to. So they will know better why you set this limits. Okay, maybe why nowadays will be more stringent, right? So it's better to list out everything in the method validation report. Try to list it out detailedly, okay? And also you have to summarize your data and your whether you meet the specification. And the most important is whether the method can be used for your routine purpose or can be used after the approval from your manager or from QA department. Okay, so you have to do some conclusion in the reports. Okay, it's not just report. Okay, here is the linearity. Here is the precision data, but you don't have any conclusion. No, you need, even though you noted it's passed, but you have to draw some conclusion. Okay, maybe even it is passed, maybe you have some certain circumstances that maybe you have some particular note point, maybe it applies to a particular range or not. Okay, so according to what you find in the validation studies, you try to draw some conclusion. Okay, let's say as what I've mentioned, the solution studies. Okay, maybe you use your studies, you have done the studies, but what can you draw from the studies? What can you conclude? Okay, maybe, okay, let's say maybe it's very stable. The standard can be put at the room temperature for, let's say, a week, according to what data that you have in your study. Okay, and maybe sometimes you do 2 time slot, maybe a week and 2 weeks. Okay, so then maybe it's not stable to be placed up to 14 days. Okay, maybe it can put up to 10 days. Okay, so you draw the conclusion in your report to let the others know that it can be placed for 10 days at most, but maybe in routine, you can put for 7 days. It depends how they will use your data. Okay, they may not be used 10 days as the longest day as the standard preparation. Okay, but you have to draw your conclusion in the method validation. Okay, so in some of the method validation report, as I've repeated and repeated, they will draw lack of the conclusion. So make sure you get your conclusion in your reports, and they miss some of the data to be included in the reports. Okay, so all the raw data should be included. Okay, the sample weight, etc., the dates, etc. Okay, this is very crucial. The Hawkless, when they perform the audit, when you perform the method validation, that you have to submit their reports, they will check it, all these items as well. And this is also some of the early process that you have to be considered, and some of them have already been covered. Okay, make sure you know what's analyzed you detect. You have to design your expected concentrations levels. Okay, any interference substance. Okay, the LOD and LOQ. Okay, so what kind of instrument that you would like to use. Okay, so you have to think about it at the very early stage when you design your validation, and also when you set your criteria of each of the characteristics specification. So this is some of the guidelines that you can refer to when you perform the method validation. So the documentations is also very important in the laboratory. Okay, so you have to list out all the important items in your test method for your routine purpose. Okay, so you have to note the safety precautions as well. Okay, because when you perform the method validation, all these items has been addressed in the method validation. Okay, so in the routine, you also need to list it out in your SOP, the standard operating procedure. Okay, to let your operators who perform the test daily, okay, should note what should be noted, okay? The scope, okay, to include the concentration, what's the sample size, etc. Okay. Any subsampling, any storage conditions. Okay. Let's say in the if you have included solution stability studies, you also need to list your suggested storage time for your standard and your sample. So if your sample is not stable, or if your standard is not very stable as well, then you have to list out to prepare the standard freshly, okay, in your normal routine SOP, okay. Any calibration, what's the number of the calibration, okay? As I've mentioned, in some of the industry, if they have just have the target concentration, some of them will use the 1-point calibration in their routine purpose, okay? But you have to justify whether it is appropriate for your case or not, okay? But remember, in the method validation, the calibration curve needs to be studied. But in the routine, it depends, okay? Some of them will use less points in the calibration curve in the routine use, okay? And the reporting values or the significant figures should also be addressed in your routine SOP, okay? And any control check samples, if it is needed, then also list in the document. Okay, so this is the some of the items that you have to be noted. So I would like to share some of the method validation protocol, the protocol and the report to you. So can you see the samples of the validation protocol? If yes, please text on the chat box, please. Okay, thank you. So this is just some of the templates in about the method validation protocol to give you some ideas. Okay, so this is some of the use of the to find the assay and the impurities. Okay, so you can see that you have to who will do the experiment, who will approve it. So you have to list it and sign it. Okay, the purpose, what kind of the analyze the target that you have to study, what kind of the characteristics that you are going to be include. Okay, you have to list it out. Okay, and what kind of materials that you are going to use. Okay, this is the protocol, not the report. This is just the protocol because you have to design it. Okay, so you will list it all at the very beginning, because when you design the protocol, then the analyst will use the protocol as a procedure to perform the method validation. okay, the studies, okay. So it will include accuracy, okay, so you can see some safety precaution also being listed, okay. And recovery, acceptance criteria, all will be listed, and how it will be prepared, the samples, it will all being listed out in the protocol, okay. So this is the protocol ideas for you, and the other one is the report, okay. The report you have to, what's the purpose? The purpose of the report is to be sure a certain things that is being validated and can be used in your routine, okay. And what is the accuracy data results, okay. What's the data, okay. And the repeatability data and the specificity data, linearity, etc., okay. So this is what's the look on the protocol and the report, okay. So this gives you some ideas, okay. And I will switch back to the PowerPoint. Okay. So I hope you all can see the PowerPoint back, right? And so just now give you some ideas on the method validation protocol and the reports, okay? And the general SOP being used in the routine, I won't share with you, okay? So just to make sure that after you your method have been validated, and make sure that you will have the report, and then by use of the data in the report, you will try to set the test documents for your routine purpose, okay? So this is what I have been taught just now. So next will be talk about the documents. Performing the experiment is very important. I noted that. Well-trained analyst is also very important for the experimental part, okay? But a good documentation practice will also be very, very important, okay? Because any data being recorded is not clearly, is not fall into the requirements of the good documentation practice, it's not a good practice, okay? So the because the document will be reviewed by the QA, okay? So make sure that you will have some clear and complete records, okay? And this is very, very important, okay? And nowadays, the document will have two types, paper and electronic, okay? So in the old days, normally it's paper-based, but now some of them will use electronic documents, okay? So it will include electronic signature as well, okay? So for the good documentation, you make sure that your records must be clear and accurate, okay? As an analyst, you have your responsibility to report the accurate result and the true result, okay? Don't make up the results, okay? And the data entry should be recorded promptly, okay? That means you have to record it immediately, okay? And let's say when you use a particular instrument, okay, if you have the data, the user logbook, okay, so if I use let's say use the HPLC in the morning on today, 24th of February, so I need to record down in the logbook when I use the instrument, okay? Let's say if anyone who use, let's say another person, analyst B will use it in the afternoon, okay? Supposedly when he used the HPLC, then on the logbook, he should see my signature, okay? Let's say date, okay, let's say today, okay, and maybe sometimes will be use the purpose. Maybe I say I perform MV, let's say, maybe some of you need to write it in more details, okay, and use by, okay, so maybe I will sign the name here, okay. So for the good practice, let's say I use it in the morning, and in the afternoon, maybe the other persons who use the HPLC, maybe he used to do the instrument maintenance. Okay, maybe another speed. Okay, he or she should sign. Okay, so I should record it down. Okay, at the time I use. Okay, so don't leave it a blank line. Okay, or actually maybe the worst case. Okay, and make sure that if I write the words wrongly, let's say I write this wrongly, then I cross it, and then I have to sign it, and then I have to date it, and maybe some of the system maybe require you to note the reason that you wrongly input the words. Okay, maybe the reason. Sometimes maybe spelling mistakes. Okay, it depends what the reasons. Okay, and don't just it will be better to just cross a line. Okay, don't just, okay, don't do like that. Okay, when you clear the when you cross the line, the original wrong data or the wrong wordings should also be observed clearly, can be seen clearly. Okay, so don't cross it like that. Okay, and another things that I would like to remind you, the date. Okay, in the QA, your quality system, you have to well define how to write the date. Okay, because if you use double digit, okay, 24, okay, so you don't know whether it is date, month, year, or year, month, or date. Okay, so you have to define in your quality system to let the operator know that in what way of the date to be input, the format. Okay, if you use the double digit. Okay, so in your quality system, no matter you use double digit or 4 digit for the year, okay, it will suggest you to list the format that you require your analyst to write it. Okay, don't try to uniform your style. Okay, otherwise the analysts don't know which format that they have to use. Okay, and also the signature. Okay, when you join in the laboratory, so it's better to sign your signature in the log sheet first, because people will note that this particular signature is whose analyst. Okay, and this B is who. Okay, and in some let's say in some balance, they will have some thermal papers to be printed out. Okay, so if you need to keep it, okay, because the ink may be fade over time, it was suggested you to have a photocopy and to be affixed next to the original one. Okay, and also we'll suggest you to give the initial on the copy and date it. Okay, so make sure that you will follow a good documentation practice in your when you're performing your lab. Okay, and this is very important. Okay, so because the auditor will also check these things. Okay, so make sure that you have the good apart from the good laboratory practice, you also need a good documentation practice in order to have a good quality system in your laboratory. Okay, so now we'll have the paper formats, and some of them will have the electronic formats. For the logbook, for the data book, it will suggest to be bounded. Okay, to have the pages to be stamped on it. Okay, to avoid any people to tear it off. Okay, and for some of the data, let's say in the validation, because you have designed your worksheet. Okay, for any places that you don't have any data, maybe you cross it out. Okay, maybe you type it NA. Okay, not applicable or other things. Okay, don't just leave it blank. Okay, make sure you will have this kind of practice. Okay, and you will have the this kind of practice. Let's say for the remaining part of the sheets, you don't have any data, then you cross it out and then NA. Okay, okay, to avoid anyone to fill in something after a certain time and then you don't know. Okay, this is not a good practice. Okay, so the last two lines is to give you an ideas what is the good documentation practice and how we expect you to have the data input and the recording in the laboratory. Okay, so I hope in the past 3 lectures, I hope I gave you the ideas on the selection of method as well as the method validation. Okay, to give you some ideas on that. Okay, so I repeat one point that the notes that I have been covered will be for both degree and master students. Okay, so for the supplementary, please, the master students, could you please take a note on your own? Okay, so that's the end of my part for the last 3 weeks. Okay, and I hope you all enjoy it, and then have a good night. Okay, and bye bye.